All right, so hopefully you're on page 14 where we left off on the other video. This is 10.3 coterminal angles, page 14 in your packet. It obviously doesn't look like this, but we're going to have this in class, and I'm going to have a spinner on it, which is kind of hard for you to see. But if you read on the top of page 14, what's going to happen is they're going to have the spinner always has to start. Let's turn to another color real quick. The spinner always has to start here, right? So right on the x-axis. So the spinner must always start from the position shown above at the top of page 14, as you can see. These are just the rules that I've set, right? And the spinner has to spin counterclockwise. So it's going to go this way. And then the only other thing is if you land on a line, you can pick which of the two sectors you land in, right? So you can, yeah, do that. So what we're going to do first is kind of go through this and then label what's going on, okay? So this is kind of how mathematicians have set up measuring angles on the x-y coordinate plane. So here we have our x-axis, here we have our y-axis, right? And so they just said the positive x-axis, this is where we'll begin. And we'll always spin counterclockwise. And the reason why that is, if you remember, just because of the positives and negatives and how they work, we call this quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. So just kind of going off of that, these are the rules set up when we're looking at angles on a coordinate plane, okay? So you can kind of see that, how I'm setting it up here. Okay, so page 14. Taryn really wants to win clean the whiteboard. What is the smallest number of degrees she can spin in order to win? Sketch the angle on the axis. So if you remember, we're going to start here, right? So draw a line right there. And then let's take a look at the spinner. So if she wins clean the whiteboard, what is the smallest number of degrees she can spin in order to win? So I want you to think about that. So the smallest amount, if we're spinning this way, right, and she lands right on this line, she's going to win clean the whiteboard, and she'll have to clean the whiteboard, right? If she goes in to clean the whiteboard, so she goes in a little farther, yeah, she'll have to clean the whiteboard, but that's not the smallest amount of degrees, right? So hitting right on the line is the smallest amount of degrees she can get and still win. So our job right now is to figure out how many degrees that is. So I want you to kind of think about that and see if you can figure it out. How many degrees is that? All right, so I don't know if you're thinking about this. There's a couple ways. But we know that a straight line is 180 degrees, right? So we know it's not more than 180 degrees. And we also know that this is probably 90 degrees. And I'm going to tell you each section is the same amount. I'll tell you that also, okay? So if you notice, we have 1, 2, 3, 4, 5, 6. Here we have 6 sections, okay? So if we do 180 divided by 6, 180 divided by 6, kind of think about that, we're going to get 30 degrees. So let's think about it. 30 degrees plus 30 degrees plus 30 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 150 degrees. All right? Okay, so it opened up about here. Here's our angle, right? That's 150 degrees. Now I want you to write right here, this is always called the initial side, and this is called the terminal side. All right. Done with number 1. Okay. So when Taryn spun, she actually spun, so she started right here. She actually spun, and it did 510 degrees. So that's kind of a lot, but it should go somewhere there. So I want you to kind of think, if she actually spun 510 degrees, what did she win? So let's look at that. Now, do we want to keep counting that? Well, probably not. But we know that if she did a full 360, right, she'd end up back where she began. So if the initial side spun all the way around like a clock and stopped right there, we'd have, like I drew, a 300 and this is getting a little wild, right? So she would have a 360 degree angle if she spun, started on, come on, let's go. Started on the initial side, went all the way around, right? Initial side and terminal side are on the same spot, 360 degrees, okay? So let's kind of think 360 plus 30, if she kept going, right? Back over, repeating a little bit. So 360 plus 30 is 390 plus 30, right? Kind of think about that, keep track of that. So we're at 390, now we're at 420, now we're at 450, right? 480, 510, boom, boom. Okay, so kind of keep note of that and let's draw it. 510 would be about there. Okay, 510 degrees. So if you looked at the spinner, we did end up landing right on the exact same spot, right? So if you remember 150 degrees, 1, 2, 3, 4, 5, 5 times 3 is 150, 510, we're on the exact same spot. These are called, 1 and 2 are called coterminal angles, right? One is definitely bigger. It spun around more times. It did more degree movement, right? It went a lot farther, but it stopped at the exact same spot, coterminal angles. And you can find coterminal angles by just taking your angle and adding or subtracting 360 degrees, right? Because you'll just do a full circle and end up where you're at. So 510 degrees minus 360 degrees gives us 150 degrees. Coterminal angles right there. All right, number 3. If you land on a starred line, you get an extra spin. And I accidentally erased a star, but I was supposed to have a star here and here. So basically, if you start here and spin it, so if you do 360 degrees, right, or 720, so you go around twice, you'd have the coterminal there. But if you land on that star, you get an extra spin. If you spin 180 and land right there, you get an extra spin. All right? So 3A, Jacob spun 170 degrees. How many degrees was he from getting an extra spin? All right, so he started, as we talked about, right here, his initial side, and then he spun, and he got 170 degrees. So I didn't spin it too hard, right? Okay, so he had 180 degrees minus 170 degrees equals 10 degrees, right? That's just kind of thinking about how far away he was. So let's draw that in here. Okay. So he was 10 degrees off. Okay. Now, so remember the rules of the game. You start on the positive x-axis and you spin counterclockwise. When you're trying to see this distance you are from the x-axis, that we just measured right there in green, as you can see, this is called your reference angle. Okay, Your distance from the x-axis is your reference angle. So we'd say we're 10 degrees from the x-axis. That just kind of gives us a reference of where we're at, right? Okay, B, Allie was 70 degrees away from winning an extra spin. How many degrees could she have spun? So she could have been 70 degrees away here. This is a reference angle again, right? So the angle, the rules of the game, you always go from your initial side over here. So this arrow on the right is the true angle, but that's our reference angle, okay? So when you go from your angle back to the x-axis, 70 degrees, okay? Sometimes your angle can be your reference angle as well, right? So if I only open up this much, that's still the distance to the x-axis. It's my angle and my reference angle at once, okay? Here, I have my reference angle, but I also have my full angle there. And here, I have my full angle, but also my reference angle. So these could all be 70 degrees in here, right? Okay, so what are those? Well, obviously we have 70 degrees. And then 180 minus 70 gives us 110. And then 180 plus 70 gives us 250. And then 360 minus 70 gives us 290 degrees. So these are all the angles, and then you can see their reference angles there, okay? So number 3, reference angles. Number 1 and 2, coterminal. Okay, so number 4, Reed broke the rules. He spun it clockwise instead. So he started here with his initial side, right? So this is called your initial side when you begin. But he decided, the dummy, right? He decided to spin clockwise. He's like, forget the rules. I don't care about those, right? He spun clockwise. So if we look at his reference angle, he's 35 degrees away. So if you spin clockwise, if you decide to break the rules, but you do follow the rules to start on the initial side, but you spin clockwise, this will be a negative degree. Okay, so he spun negative 35 degrees. Now the coterminal to that, so that's what he did, that's the movement he did, right? And the coterminal would be 325, right? Because the whole way around is 360, but we take out that 35 that he spun, so there's a coterminal if he would have spun clockwise. But he didn't. He spun, if he would have done counterclockwise if he was supposed to. But he spun clockwise, which gives him a negative angle. All right, so we have coterminal angles, so you spin and land either smaller, amount of degrees is either smaller or bigger, right, than just a basic angle, right? So we could add 360, we could add 360 again. We could keep adding 360 to 150 and keep getting more and more and more coterminal angles, okay, like we did here. So 510 degrees is coterminal with 150. Okay, and there's more we could do, right? We could keep adding 360, keep spinning it more. We also learned about reference angles real quick right here, right? So references angles are when you measure from your terminal side to the x-axis. Sometimes it'll be your legit angle. Sometimes it won't, right? Sometimes it could just be negative, but the reference angle we will write as positive, okay? But it's the distance from the closest x-axis, basically. And then if you decide to spin clockwise, you're just going to write your degree as a negative. Okay, and the last thing is we can use points because we are, I mean, you don't see it, but we are working, right? So think of graph paper. Pretend I have some graph paper right here. We are working in an XY plane. I'm just not showing, I haven't labeled my X and Y axis, so it does look a little weird. But if I were to label it, and I went right 2 and up 3, right? So I'm just reminding you, these are all labeled, I'm just, no point in them so far, but now we have a point. Okay, so if I go over 2 and up 3, okay, what angle did she spin? So there's where she spun, here's her initial side, right, terminal side, how far did she spin? Well, who the heck knows, right? But it gives us a hint. It says draw a triangle. So we know this is 2 long and 3 long. We know it's a 90-degree angle because we went over and up, and we know it has to be perpendicular, right? So we have a little triangle right here. I'm going to use the Pythagorean theorem real quick. Actually, I don't need to use the Pythagorean theorem, right? I was, but then I just looked at it and decided I don't need to. I have a triangle. It's 2 long, 3 long, and I need to find this angle. Oh yeah, 10.2, right? So we got to look at what we have. If this is our angle, we have opposite and adjacent. Opposite's 3/2. That's inverse tangent. Okay, so if I put that in my calculator, I get 56.31 degrees. Awesome. Okay, so what did we learn? What was important here? So we first learned about standard position. Okay, so standard position is this concept that we can measure angles and put them on, y = mx plus b, a normal ordered coordinate plane. Sorry, couldn't get the words out quick. So we can graph on an xy plane, a coordinate plane. Our initial side is here. And we'll have a terminal side somewhere else. Okay, so it's an angle. Now putting that all into words, it's an angle with a vertex at the origin. Getting a little wild there. At the origin, and one side on the positive x-axis. That's our initial side, right? And the other side of the angle is called the terminal side. If we spin, so we have our initial side, we have our terminal side. If we spin counterclockwise, it'll be a positive degree. If we spin counterclockwise, it'll be a negative degree. All right, so that's the first idea that we saw. Next is coterminal. Okay, so angles in standard position that share a terminal side. And remember, we're going to add or subtract 360 degrees to find that. And the last thing we talked, well, not exactly, but we also talked about a reference angle. Okay, and that's when you measure an angle from the terminal side to the x-axis. Okay, all right, so you have a little bit room down at the bottom, a teeny bit. What I want you to do right now is we're going to look at a few more examples real quick. Okay? So right here, we have 580 degrees, and it wants us to find the reference angle. 580, find the reference angle. So we spun counterclockwise, as you can see, which is good. So we know that obviously it's a positive 580. So what I'm going to do is I'm going to minus 360 here, right? So I'm going to kind of simplify this down. Minus 360, 0 minus 0, 0, 8 minus 6 is 2, 5 minus 3 is 2. So a coterminal angle that would be a little bit easier to work with is 220 degrees, right? So if I'm 220 degrees and to here is 180, I know that I went an extra 40 degrees. So from here to here, boom, 40 degrees. That's my reference angle. Okay, let's take a look at this one. So I decided on this one to go clockwise, right? So I did 360 degrees, boom, 360 degrees. Then I did some more. So what we're going to do on this one is we're actually going to add 360, okay? So 0, negative 9, and 6. What will that be, right? A negative 30, technically, and then negative 4 plus 3. So we have negative 130 degrees, right? Negative 130. So from here to here, 130 degrees. Negative, right? So if we find our reference angle, so we look what quadrant we're in and we go back to the x-axis, the closest x-axis we can get to, right? Our reference angle, so 180 minus 130 is 50 degrees. Even though we spun in negative, our reference angle is always positive, so that'll be 50 degrees to complete us back to the x-axis. All right? So we have a coterminal angles right there. We have our reference angle. All right, let's do another one. So to get us back to the x-axis, we're in our simplest form right here at 315. We can't get any simpler than that, really. Okay, so 315 to 360. I'm going to do 360 minus 315 and see where I'm at, right? So I'm going to borrow from there. So I'm going to be left with 5, right? And then 5 minus, what am I doing? Oh yeah, it was 360, duh. 5 minus 1 is 4, 3 minus 3, so 45 degrees is my reference angle. Awesome. All right, so find the measure of each angle. How the heck many times did we spin? So it looks like we did 360, right? And not quite 360, but plus, so we know we did 360 plus 90. Well, let's keep this a little bit simpler. Okay, we're getting a little crazy here on our drawings, right? Okay, so here's our 360 done. Here's 180 plus 90. It's going to get us 270, all right? 180 plus 90 is 270. Then it's telling us right here we have 75. Now notice, which way did we spin? We spun clockwise. So we know that it's going to be negative when we're done. But I am going to add all these up. So 5, 7 and 7 is 14. 14 plus 6 is 20. So we have 1, 2, 3, 4, 5, 6, 7. 700, negative 705 degrees is how far I spun there. Okay? Okay, notice this one. 180 plus 50, 230 degrees. I spun counterclockwise, right? 180 plus 50, 230. All right, so what I want you to do now, is turn the page to page 16. Now your homework's not too long today. You only have 3 problems. So give that a try, see how you do, and then I'll go over it before the next lesson. Awesome. Good work.